So this question is, okay, there's a reaction that's going on, and he's saying when solutions of chlorine are used for water purification, the pH of the solution of chlorine is kept near to pH 7 by the addition of a base. Chlorine is dissolved in water to produce a 1000 cm3 of a solution containing 0.170 moles. So it contains 0.170 moles of HClO and 0.170 moles of HCl. So I think what he's doing is he's dissolving Cl2, right? It's this one, and when he dissolves it, the 0.170 moles of HClO are produced. So 0.170 moles of HClO and 0.170 moles of HCl. HCl in aqueous solution would dissociate, so this is HCl. 0.170 moles of this. And remember, it's a 1000 cm3 solution, which is basically 1 dm3. So that kind of indicates that the concentration is the same as well. It's 0.170 mole per dm3 and 0.170 mole per decimeter cube. And then he says that a buffer solution is then prepared by adding 0.2 moles of NaOH to the solution. So you have this solution. You've got a 1 dm3 solution. What he's doing is adding NaOH. And how many moles of NaOH is he adding? He's adding 0.2 moles. So 0.2 moles of NaOH are being added. The NaOH reacts initially with the HCl, so that is also given. So this NaOH over here, so let's carefully assess what's going on. Cl2 has already been dissolved in water. 0.170 moles of this and 0.170 moles of this are produced. Okay, that's one thing that he did mention. And then he says that a buffer solution is prepared by adding NaOH. And the NaOH initially reacts with the HCl. So the NaOH is going to go and it would initially react with the HCl that's over here. Okay, these two things are going to react first. So I'm going to write down the reaction, what happens when NaOH reacts with HCl. Okay, that's the simple reaction. It produces NaCl and H2O. Okay, so keep following. We've reached this point at the moment. NaOH moles are 0.2. So you got 0. And how many moles of HCl are present? The amount of moles of HCl that are present are 0.170 moles. So this is 0.170 moles. Can anyone tell me which one is in excess? Like the two would react. Which is in excess?
NaOH.
Okay, so NaOH is in excess. That means 0.17 moles, it's 1:1, right? So 0.170 moles would react with exactly 0.170 moles. That means 0.03 moles of NaOH would be left. They are not going to react. So 0.170 moles would react with 0.170 moles to produce 0.170 moles of NaCl and water. So 0.17 reacts with 0.17. So you've got NaOH that is left. हाँ साकिब आवाज आ रही है? ठीक है. I say anyways, so you've got NaOH that's still left. And then he says the NaOH reacts initially with the HCl. So it has obviously reacted with the HCl. Now moving forward, this one is also an acid. HClO is an acid. So the remaining NaOH, now this NaOH over here has initially reacted with the HCl. So they did mention that in the question that it initially reacted with the HCl. Now it's going to react with the other acid, which is HClO. So the leftover NaOH now, how many moles were left? It was 0.03 moles, right? It's going to react with the other acid, which is HClO. And a salt is going to be produced, which is going to be NaClO. That is how salts are always produced, plus water. Whenever you want to produce a salt, the H in the acid is going to be replaced by Na. And so I'm just going to go over this question one more time, because this question has a lot of steps. The first thing that he said was that chlorine is dissolved in water. This is chlorine reacting with water, and he said that 0.170 moles of HClO and HCl were formed. So HCl and HClO. 0.170 moles of both were formed. And then what he did was a buffer solution was then prepared by adding 0.2 moles of NaOH. So he added NaOH and he added 0.2 moles of NaOH into the mixture, which contained HCl plus HClO. And he clearly stated that the NaOH was initially reacting with the HCl. So we made a reaction. We said that NaOH reacts with HCl. And 0.2 moles would react with 0.170, but 0.2 is in excess, so 0.17 would only react with 0.17. So that means 0.03 moles of NaOH would be left. And then the leftover NaOH would react with this other acid. So first, it would react with HCl, and whatever is left would react with HClO. Is this clear to everyone? Zaib, is this clear, Zoha?
Yes, sir.
Yes, sir.
Now you have this leftover 0.03 moles. HClO moles, he already said that they were 0.170 moles of HClO in the solution. Now which one is in excess? It's HClO that's in excess. It's 1:1, so 0.03 are going to react completely. And they're going to react with 0.03 exactly. So that means you'll be left with 0.14 moles, I think. Right, out of the 0.17, it's 1:1, so 0.03 are going to react with 0.03. So 0.14 moles of HClO would be left in the flask. Is this clear?
Yes, sir.
And 0.03 would react with 0.03 to produce 0.03 moles of NaClO. So that means at the end of the day, you'll have the salt of HClO in the flask, and there's going to be leftover HClO as well. I mean, this contains the ClO minus 1 ion, which is the conjugate base. This contains the acid, which is HClO. So the flask would contain the salt that is produced, 0.03 moles of NaOH, which were left from the previous reaction. They're going to react with HClO to produce 0.03 moles of NaClO. That is going to be produced, and out of the 0.17, not all of it would be able to react, because 0.03 would only react with 0.03. So that means 0.14 moles would be left at the end, unreacted. And your flask would contain the weak acid plus its conjugate base or salt as well. So is this clear so far?
Yes, sir.
Yes, sir.
TK, remember this one is a slightly difficult question. TK, so Sohail, is this clear?
Yes.
Now the next part is what was the next part? He's saying a buffer solution is made. A buffer solution is definitely made because you've got a weak acid plus its salt as well. So and he's asking you to calculate the pH of that buffer solution. So what is the buffer solution? It's the weak acid in equilibrium with its conjugate base, which is ClO minus 1 plus H plus 1. These are how many moles? These are 0.03 moles, right? Coming from the salt, which is NaClO. So 0.03 moles, and the leftover acid is 0.14 moles. So your solution contains 0.14 moles of this. Since it's a dissociation, it is an acid that is, it's an equilibrium reaction where the acid is dissociating. The same K would apply. It's the K value is already given as 2.9 times 10 power minus 8. Products over reactants, it's 0.03 times H plus 1 concentration, and the whole thing would be divided by 0.14. So what do you get? What is the H plus 1 concentration? And then take the negative log and find and tell me what the pH is.
$12.5.
Are you sure? I mean, I don't know. It's
Sir, I'm getting
6.87.
6.86.
Yeah,
okay, that's 6 point.
6.87.
Yeah.
So you're getting 6.7. So 6.7 is probably the answer to this question. Just make sure that the accuracy, everything is given up to 3 significant figures, except for this one. This is actually given to 2 significant figures, so you can round it off to use the least significant figures that are there. So that is going to be 6.7. Okay, is this clear?
Yes, sir.
Okay, just the issue is that this question was difficult. Okay, I mean, it wasn't difficult. They just had a lot of steps in this. And at the end, you had to reach this point. You had to figure out how a buffer was being formed. Okay, so I mean, the question was easy. 0.170 moles of this and 0.170 moles of this were produced. He added 0.2 moles of NaOH. Then he told you exactly that it was initially reacting with this. So, which meant 0.17 would only react with 0.17. So 0.03 would be left. So the remaining 0.03 was reacting with HClO. So 0.03 would react with HClO. So out of the 0.17, only 0.14 would be left. And 0.03 would react with 0.03 to produce 0.03. So you found the moles of the conjugate base as well as the weak acid as well. Now, so this one was kind of tricky. I said this one. Let's move to this one now. Explain why this value of K is much larger than that of ethanol. So this is about the organic thing that we discussed right at the end. You've got ethanoic acid. It's OH. The bottom H dissociates, ionizes, it leaves. And you've got ethanol, which is CH3CH2, and O minus 1 and H plus 1, right? So that's an alcohol. I've shown them all, both of them dissociating. It's OH, this is also OH. Which one is a weaker acid? We already know that this one is a weaker acid, so it doesn't like to dissociate. Why doesn't it dissociate? Because it's got a carbon chain which has an electron donating effect. So the negative charge over here is going to become large because of that. So this is what you're going to mention. And if it becomes larger, it would attract the H plus 1 back again. It will not allow the H plus 1 to be produced. Is this clear?
Yes, sir.
Yes.
So what about, and you can also explain this one, why is this a strong acid? Because the negative charge is smaller, because you've got an oxen over here, and the oxen kind of, it's an electronegative oxen, which pulls the electrons away from the, so the negative charge at this point would decrease because it gets withdrawn to the other oxen atom. So the H plus 1 is not really going to be strongly attracted to the negative oxen over here, because the negative charge gets pulled towards the other oxygen atom. So the explanation, the way you're going to write this is, because there's just two lines, so you're either going to mention about the alcohol or the carboxylic acid. So we can talk about the carboxylic acid. So oxygen, you can talk about the electronegative. So you can talk about the electronegative oxygen. In C double bond O has an electron withdrawing effect. Which makes the ion stable. Or you can talk about its charge density. You don't have a lot of lines, so that's it. That's pretty much all you're going to mention over here. And what about chloroethanoic acid? So now he's comparing ethanoic acid with chloroethanoic acid. So chloroethanoic acid is going to be pretty much the same thing. It would be CH2, C double bond O, and OH. The H, let's assume it dissociates, but it's got one thing else. There's a Cl. So the negative charge over here is getting withdrawn by the oxygen over here, but there are two things that are withdrawing. There's a Cl electronegative oxygen as well. That would also withdraw the electrons towards itself. So the negative charge at this point is going to be a lot lesser. Is this clear?
Yes, sir.
So you're going to talk about chlorine, electronegative, what's the spelling? Electronegative. And withdrawing effect. Okay, so you're going to talk about that, and you're going to talk about this Cl, CH2, CO -1 being stable. I mean, the negative charge would be lesser, so it won't attract the H+1. So is this clear?
Yes, sir.
Yes, sir.
The next one is kind of easy. It's simply ethanoic acid. And he's asking us to figure out the pH. I mean, ethanoic acid dissociates, produces CH3CO -1 ion, and releases an H+1. So it's going to be product. K would be product over reactants. These two ions would have the same concentration because there's just ethanoic acid. So if it dissociates, the two ions are going to be produced in exactly the same quantity. So you're going to call this H+1 squared divided by the concentration of the acid, which is CH3COH. So K value is already given. That's 1.75, I think, 10 power -5. H plus squared divided by the acid concentration, which is also given, which is 0.1 mole per dm cube. So that's 0.1. So can anyone tell me what is the pH of this?
.88,
Kitna?
2.88.
It's coming out to be 2.88. Make sure 3 significant figures because the concentration was given up to 3. It was accurate up to 3 significant figures. So is this clear?
Yes, sir.
Adam, is this clear? So now next is, now what is he up to? What he's doing is he's trying to create a buffer now. what he's doing is that he's taken 10 cm cube of 0.1 mole per dm cube ethanoic acid. So let's assume there's a flask, and that flask contains ethanoic acid, which is CH3. And it's 10 cm cube. And can anyone tell me how many moles this is? Concentration times volume, what do you get for this? Ten into 0.1, is it 1 times 10 per minus 3 moles?
Yes, sir.
I said, now what is he adding? So NaOH was slowly added to this. So NaOH is 20 cm cube of 0.1 mole per dm cube. So from the top, he's adding NaOH. And the amount of NaOH that's being added is 20 cm cube and 0.1 mole per dm cube. So how many moles is this? I think 2 times 10 per minus 3 moles.
Yes, sir.
So you're adding 2 times 10 per minus 3 moles. At the bottom, you've got 1 times 10 per minus 3 moles of ethanoic acid. So that kind of indicates that he's adding too much NaOH. Like NaOH and ethanoic acid, they react in 1:1. I can write an equation somewhere. So it's an acid-base reaction. The salt is going to be produced. The acid would lose its H. Na would take its place, and the H would react with OH to form water. So this is the reaction that's going on. Calculate the number of moles of NaOH remaining at the end of the addition. So at the end of the addition, so we did calculate the moles. It's 1 times, how many moles do we have for ethanoic acid? We've got, for ethanoic acid, we've got 1 times 10 per minus 3 moles. And for NaOH, we have 2 times 10 per minus 3 moles. So 1 times 10 per minus 3 moles reacting with 2 times 10 per minus 3 moles. Now it's 1:1. So all the ethanoic acid would react. 1 times 10 per minus 3 moles are going to react with 1 times 10 per minus 3 moles. So that means this has been added in excess. By how much? By 1 times 10 per minus 3 moles. Like 1 would react with 1. 1 times 10 per minus 3 would react with 1 times 10 per minus 3. You don't need 2 times 10 per minus 3. So that means 1 times 10 per minus 3 moles are in excess. Is this clear?
Yes, sir.
Yes, sir.
Yes.
Achha, so he's saying calculate the number of moles of NaOH remaining at the end of the addition. So we did, it's 1 times 10 per minus 3 moles, right? So that's the moles of NaOH. Calculate the OH concentration. Remember, the OH ions would be exactly the same because it's a strong base. So its concentration would be, sorry, its moles would be exactly the same. To find concentration, remember square brackets is concentration. You have to find concentration. You already have the moles, like NaOH moles and OH ions, they have the same moles. How do you find concentration? Concentration is moles divided by volume. You do have the moles, 1 times 10 per minus 3. So what is the volume after the addition? Like you're adding 20 cm cube to 10 cm cube. So the final mixture would have how many cm cubes? 30 cm cube. Is this clear as well?
Yes.
Yes, sir.
Which is in dm cube 0.03 dm cubes. So that's your moles divided by volume. Can somebody tell me what's the what's the concentration that you're getting? Is it 0.33 or 3.33? What do you get?
Zero point 0.33.
So the concentration is 0.33 mole per.
Wait, sorry, 0.03.
Is it 0.033? I think it's 0.33.
Yes,
Or is it 0.033?
0.0.
So it's coming out to 0.033 mole per decimeter cube. Okay? That is what you're getting, and we can keep this to 3 significant figures because these values were given up to 3 significant figures. Now use the expression calculate H plus 1 concentration and the pH. Now the two ways you found the OH ion concentration, right? So you could calculate pOH and then you can find pH, right? The other one is you have the expression for Kw. The value of Kw is 1 times 10 power minus 14. The H plus 1 concentration is not known, but the OH ion concentration is known. It's 0.0333 mole per dm cube. So from that you can find pH, calculate H plus 1 and then calculate pH.
Sir, I'm getting 12.5.
Keval, what's the value are you getting?
12.5.
12 point?
5.
So you're getting 12.5 for this. Okay, so we're getting 12.5 for this. Okay. Is this clear?
Yes,
Yes.
sir.
And I think they're going to ask you to sketch a graph. So the final, like when you added 20 cm3 of NaOH, what's the pH? 12.5, right? Something, this is 13, this is 12, so somewhere over here, right? And you also have the final, the initial pH when you did not add any, you did calculate the pH of the carboxylic acid. 0.1 mole per dm cube because he's using 0.1 mole per dm cube of carboxylic acid. So you did calculate the initial pH, like when there was only acid present over here, 0.1 mole per dm cube, the pH was 2.88, right? So this one is 2.88. Is this clear? That's your initial, like the final, that's your starting pH when you did not add any NaOH. And then when you've added the whole NaOH, that's your final pH. Is this clear so far?
Yes, sir.
Okay, so you're getting 12.5 and this was I think 2.88. Now, there's only one thing missing, and that is at what volume of NaOH was the equivalence? What was the neutralization point? Like they have the same concentration. So you have 10 cm3 of ethanoic acid over here. So how much of NaOH was needed to completely neutralize the carboxylic acid? I mean, they have the same concentration. So 10 cm3 was going to react with 10 cm3. Is this clear as well?
Yes, sir.
Okay, because 20 cm3 wasn't needed. You didn't need these many moles. You just needed 10 cm3. Okay, it was clear over here as well that you added too much NaOH. I mean, you added double the amount of NaOH that was needed. Like 1 times 10 to the power minus 3 moles was only going to react with 1 times 10 to the power minus 3 moles. So you added double the amount. You just needed half of that. So 10 cm cube was just needed. So at 10 cm cube, there must have been neutralization. So at 10 cm cube, the pH would be crossing 7 because at that point, ethanoic acid would have been neutralized. Adding more NaOH would make it basic. So is this clear so far?
Yes.
Okay, and this is how pH curves were plotted. What you had to do was you had to mark these 3 points and then make an S-shaped curve. Initially, the pH changes very little, and at around the equivalence, it's almost constant. So that's your final. pH over here. See, that's going to be your graph. It's going to look like this. We can have a quick comparison of this. It's S14 QP40. Just 1 second. Just to compare the two graphs that we have made. And there must be a graph somewhere. So it's 2.88, that's fine. Vertical, so they're basically just, they're not even looking or giving marks for the shape. I mean, they have given marks for the pH curve. It should be an S-shaped curve. So they're not being very specific, just the volume at 10 cm cube. So vertical, they're saying that should be at least 2 pH units. Our vertical point is definitely more than 2 pH units, right? So that's the vertical part. So pretty much everything is fine. And you have to choose an indicator for this titration. Now, the indicator is that you shouldn't have added more NaOH. Like at 20 cm, I mean, once 10 cm cube was added, you should have stopped adding NaOH. So the indicator is going to help you figure that out. The indicator should change color when this pH is crossed. So 0 to 1 is not going to work. 3 to 4 is probably not going to work as well because if it's changing color at 3, so the color might change at this point because this is 3, right? So you don't want it to change color at this point. You want the color to change when this pH is crossed. So 9 to 10 is going to be a perfect. That's going to be perfect because 9 to 10 is somewhere. 7, 8, 9 to 10 is this part. So it's going to change pH at between 9 to 10. The other ones will not work. 1 to 2 will definitely not work because the pH curve never goes to 1 to 2 or 0 to 1. 3 to 4 might work, but it would change color somewhere at this point. You don't want the volume, you don't want to stop adding NaOH at this point. You want to stop adding NaOH at this point. Okay, is this clear as well?
Yes, sir.
Yes.
So the indicator must change color at the neutralization point when the pH is in this range. Solubility product we haven't done. So we're not even solving the upper row. You get no idea why we moved down, as these were the latest questions. As anyways, we can, try doing, you have the worksheet, try attempting these 2 pages. The first, this is the first page. You actually missed a lot of pages. Try doing the second and third in the worksheet. Let's continue tomorrow then. Okay, these latest questions are slightly more tricky. Not tricky, but kind of different from the previous older ones. Try attempting this worksheet. At least the first 3-4 pages. Okay, any questions? Is this all clear?
Yes, sir.
So let's continue tomorrow. Take care.
Thank you.
Thank you, sir. Allah Hafiz.
Hafiz.